Creating a human life in a laboratory? It sounds like something straight out of science fiction, right? But for millions of people, it's a reality. It's called in vitro fertilization, or IVF, and it's a technology that has totally changed what it means to build a family. So how on earth does it actually work? Well, let's get into it.
So, where did this all begin? Well, you have to go back to 1978, with the birth of a little baby girl named Louise Brown. She was the world's very first IVF baby, and her arrival, wow, it kicked off an absolute revolution in reproductive medicine that's still going strong today.
And when I say revolution, I mean it. To put this in perspective, since Louise Brown was born, IVF has brought more than 5 million babies into the world. Just think about that number for a second. It's staggering, and it really shows you the massive impact this has had on families all over the globe.
So why is the demand for IVF growing so much? Well, a huge part of it is that roughly 1 in every 8 heterosexual couples struggles with infertility. But it's also become an absolutely vital tool for same-sex couples and for single parents who want to have children.
But here's the thing, and this is probably the most important part to understand. IVF isn't some strange, unnatural science. At its very core, it works by mimicking the brilliant, elegant design of natural reproduction. So if we want to understand what's happening in the lab, we first have to take a look at the original blueprint.
All right, so let's dive into that natural blueprint. It's a truly fascinating biological process, a step-by-step guide that science has learned to follow and even enhance.
And believe it or not, it all kicks off in the brain. A tiny gland sends out a hormone called FSH, which basically tells the ovaries, okay, time to get a few eggs ready. As those eggs grow inside their little sacs, or follicles, they start releasing estrogen. Now usually, only one follicle wins the race and becomes fully mature. That peak in estrogen then sends a signal back to the brain, which responds with a big surge of another hormone, LH. And that's the final trigger that releases the egg. It's a beautiful, intricate hormonal chain reaction.
Now that egg isn't just floating around unprotected. No way. It's surrounded by this incredible suit of armor called the zona pellucida. It's a thick shell made of sugar and protein, and it has one absolutely critical job. Let a single sperm in and then immediately slam the door shut so no others can enter.
Okay, so once that one lucky sperm gets through, fertilization happens. And that's when the real journey begins. Over the next few days, the fertilized egg, now called a zygote, starts dividing again and again, all while it's traveling down the fallopian tube. Then, about a week later, it reaches its destination and snuggles in, implanting itself firmly into the lining of the uterus.
But wait, there's one more crucial piece to this puzzle. Once the embryo implants, it sends out a signal. This signal tells the empty follicle that released the egg, which now has a new name, the corpus luteum, to start pumping out progesterone. That's the hormone that's essential for keeping the pregnancy going until the placenta is developed enough to take over the job. It's all so perfectly connected.
Okay, so now that we have that natural blueprint in our heads, let's switch gears and see how science so cleverly mimics each and every one of those steps inside the lab. This is where it gets really interesting.
And here's the first big step where science intervenes. Remember that FSH hormone from the brain? In a natural cycle, the body produces just enough to mature one egg. But in IVF, as you can see, doctors give controlled, higher doses of that same hormone. The goal? To essentially supercharge the ovaries, encouraging them to produce multiple mature eggs all at once instead of just one.
So once those eggs are ready, they're carefully collected using a very thin needle, which is guided by an ultrasound. At the same time, a sperm sample is collected and specially prepared in the lab. And then it's time for the main event. The eggs and sperm are brought together in a petri dish, creating the perfect environment to mimic what would normally happen deep inside the fallopian tube.
Now, fertilization in the lab can happen in one of two ways. In what's called standard incubation, the eggs are just placed in a dish with thousands of sperm, and, well, nature's left to take its course. But for cases where there might be issues with sperm quality, or just to maximize the odds, they can use a technique called ICSI. That's where an embryologist selects a single healthy-looking sperm and, using a microscopic needle, injects it directly into the egg.
So, fertilization is a success. We now have an embryo. And at this point, it begins its own unique journey, moving from that petri dish towards a potential pregnancy.
At this early stage, a few different paths open up. The tiny embryo can be genetically screened to check for any abnormalities. It can be frozen, a process called cryopreservation, to be used at a later time. Or it can be chosen for immediate transfer into the uterus.
Now, the timing of that transfer is another key decision. Sometimes it's done on day 3, when the embryo is just a little ball of a few cells. But often, doctors prefer to wait until day 5. By then, it is developed into something called a blastocyst, a much more advanced structure with hundreds of cells that is generally considered more robust.
What's also amazing is just how flexible this technology is. If a person's own eggs aren't viable, for example, donor eggs can be used. And if someone isn't able to carry a pregnancy, a gestational carrier can have the embryo transferred to them and carry the baby for the intended parents. It just opens up so many possibilities.
So, what does all of this mean for the future of how families are made? Let's take a look at the success rates, the safety record, and what might be just around the corner.
Let's talk about success, because it's really tied to a woman's age. For women under 35, the chance of a successful pregnancy from one IVF cycle can be as high as 40%. But, as you can see here, those odds do, unfortunately, start to decline as a woman gets older.
So you've probably heard about IVF in twins, right? Why is that so common? Well, historically, to try and boost the chances of success, doctors would often transfer more than one embryo at a time. Of course, that led to a lot more twins and triplets, which can carry health risks. That's why today, modern clinics really focus on transferring just a single healthy embryo whenever possible.
But of course, the most crucial question is it safe? Well, after decades of data and millions of babies born, the answer seems to be yes. These children have, by and large, lived perfectly normal, healthy lives. And for the women undergoing the procedure, it also appears to be safe.
And all of this leaves us with a pretty powerful thought to end on. As genetic testing gets better, and as people continue to have children later in life, some experts think it's not totally inconceivable that making babies in a lab could, one day, become even more common than the old-fashioned way. It's a pretty wild idea to think about.